So here's weekly review number 11. We've got a constructed response question that we're checking out this week. And if we read the situation that we're presented with, we've got someone who sells baseball programs at a stadium. We've got a function, so this would not be m times x, right? It's m of x. So m of x equals 2.50 times x, and that represents the total amount of money that he collects in dollars for selling X baseball programs. So I think it's pretty significant, this little end statement here. X is the number of baseball programs being sold. And so what they ask us to do in part A is they ask us to fill in a table with the amounts of money collected for selling baseball programs. So if we sell 150 programs, that's our value for X, right? So this is an X. So if I want to figure out how much money he's going to collect by selling 150 programs, I just need to put 150 in place of the X and get my answer. So M of 150, so I've replaced the X right here with 150. My job is to replace the X on the other side with that same thing. So I put the 150 in place of this X. 250 times 150, throw that into the calculator. We figure out he's going to collect $375 if he sells 150 programs. Similarly, we put 175 in for X. 2.5 times 175 gives us that amount of money. And then if he sells 197 programs, 2.5 times 197 in for X is going to give us that amount of money. So basically they give us this function and they ask us to find three different function values. We want to know the M value, the money value at this X, at this X, at this X, and there are the answers. In part B, they start talking about the cost of printing these programs. So the cost in dollars to print up X programs, so X is still a number of programs, for each game is represented by this function, C of X. So again, it's not C times X, it's C of X. So we've got 0.50x plus 40. It asks us to draw a line that contains the coordinate points of the cost to print up to X programs for each game. Now this is phrased in a really weird sort of way, but basically they just want us to graph this function. And if we want to graph this function, what you can do is, this is a swap that we've made a little bit this year. We can swap out the function C of X for a Y. So if Y is equal to all of this, and you see the reason why we can do that is C of X is plotted on the Y axis, so Y and C of X are really the same thing. So I've put Y in place of C of X, and I want to try to graph this. Well, what I notice about this equation right here is it's in slope-intercept form. My slope is 0.5. My B value, my y-intercept, is positive 40. I know I like to have my slope written as a fraction, so I can do a rise and a run with it. And so I went ahead and I rewrote that one more time. I rewrote the 0.5 as 1/2. So I've got a slope of 1/2. I've got a B value for the y-axis of 40. So I began my graph on the y-axis at 40, and then I realized I wanted to use this as my rise and my run. So I have a 1/2. Now I had to be a little bit careful here because if I go up what looks like 1, I've really gone up 10. So if I go up 10, how far over am I going to have to go? Well, if we look at the scaling on the x-axis, it's by tens as well. So if I go up 10, I actually go over 20, and I put a point here. And a rise of 1/2 is equivalent to a rise of 10 over 20 because these two fractions equal each other. 10 over 20 reduces back down to 1/2. So I rise 10, I run 20, put a point. Rise 10, run 20, point. Rise 10, run 20, point. Connect the dots, and we've got a line, we've got a line that contains the points to print up X programs. So basically what this is good for, if we want to know how much it's going to cost to print, say, 70 programs, well, 70 is on the x-axis right here. If we go up to our graph, what are we looking at? Well, we don't know for sure, but it seems like it's really, really close to like $75, right? So X is the number of programs being printed, and then the Y is the cost to print that many programs. The last question here is the trickiest one in this particular problem, and it's talking about on top of the money he's paid every hour, he's going to earn a bonus when the amount of money collected is greater than the cost to print the total number of programs that he sells. So whenever he brings in more money than it costs to print those programs, he's going to get a little bit of a bonus. It goes on to say the bonus is equal to half of the difference between the amount of money collected given by m of x, and the cost given by that function from part B, c of x. Part C goes on to say, how much money does Albert earn as a bonus when he sells 309 baseball programs? Show all your work, explain why you did each step. So the approach that I took here was I kind of made myself a T-chart, and for every step of work that I did over here, I just took a minute to kind of explain why I did that step. Just a nice way to keep everything nice and organized. And so what I wanted to figure out is I realized that I needed to know the amount of money he collected by selling that many programs. So the amount of money he collected is going to be found by putting 309 in place of this x. So I do 2.50 times 309. This is how much money he's going to bring in if he sells 309 programs. And then I went ahead and explained why I did that. Well, I wanted to know how much he brings in. So I multiplied 2.50 and 309 together, and now I know that he's bringing in this much money if he sells 309 programs. So I've got the first thing that is part of the difference that determines his bonus. The second thing is the cost to print that many programs. So how much does it cost to print 309 programs? So I just copied out my cost function here, 0.5 times the 309 in for x plus the $40. The cost to print those 309 programs is a little bit under $200, $194.50. And I just have my explanation there. I found the cost of producing or printing 309 programs by finding C of 309. I then realized that the bonus that he's getting is equal to half of the difference between the amount collected and the amount spent to print. And so I figured out the difference between the amount collected, so the answer for this first step, and the amount that it would cost to print that many programs. So the difference between those two is $578. And I'm just explaining why I did that. I found the difference between the income, the money he brings in, and the cost to print that many. And then the last part, I wanted to find his bonus. So his bonus is equal to half of that difference. And so I just took the difference, 578, multiplied it by 1/2, did that calculation on the calculator. Nice little bonus he's going to get if he sells 309 programs. He's going to get $289 as his bonus. And then why did I do that? Well, the bonus is half of the difference from step 3.